can't make it today. Okay, so we're looking at 3D coordinates today. In the real world, points in space could be located if you use what we call 3D coordinates. So for example, be surprised that the software used for our air traffic controllers find location by height and a reference on a grid. So that's how they give a position. So when they've got to deal with quite a few planes, it's always good to know where they are, at what position, how far they're going, and how far they're moving. And that's what they use. They use this grid reference. And in order to do that, they give you a coordinate in X, a coordinate in Y, and a coordinate in Z. So you've got X, Y, Z, and that gives you exactly where your plane is using X, Y, Z. Okay, so when it comes to vectors, one part, you've seen it on some past paper question, is they're going to ask you to find coordinates of different points when they give you like a diagram of some sort. So we need to find a strategy as to how we're going to find the coordinates of the points, okay? So here, going from 0, our reference point to C, I've got 6 units. Going from C to D, I've got 1 unit, and going from D to A, I've got 2 units. So the 2 units is going to be along Z, the 1 unit is going to be along the Y-axis, and the 6 is along the X-axis. So we might be given just these, and then the question they're going to ask us is write down the coordinates for the 7 vertices. So I've got 1, 2, 3, 4, 5, 6. So 7 here that you can see. Obviously, there's an 8th one, and it's hidden at the back there. Okay, so that could be a question during an AT5 exam. How do we figure out to write the coordinates? So the first one here, A, we said we've got X equal to 6, Y moving along 1, so equal to 1, and Z equal to 2. So you just write the coordinates 6, 1, 2, as if you were writing X, Y, Z as coordinates. Okay.
Yep.
So you might think, okay, that was quite an easy one to find. But when it becomes a bit more complicated is when you're going to have a plane where one of the 3 components is equal to 0. For example, B. So if I'm looking to find the coordinates for B, what I usually do is I look at X first and try to draw a line that goes down and cut the X-axis. So if you look at it, if I was to draw a line from B towards the X-axis, I'm cutting here at that point C. And what we said earlier on is C is at 6 units from the center 0 here. So that means my X coordinate for B is the same X coordinate that I'm using for C. So you write 6. Now to find the value for Y here, in order to move along the Y-axis, I would need to go from B towards A, and from B towards A, I would move by 1. And if I was to move on a negative side, I would move along here. So if you look at it, if you go along the way here to F and down, we're cutting here the Y-axis at its 0 point. Okay, it's as if you've got a plane here cutting your Y-axis at 0. So we've not moved along the Y-axis when it comes to B. And that's why you've got the Y equals 0 here. And in terms of Z, we are up from 0. So anything going up and down is the Z axis. And we up by how much? We're up by 2, because A here tells me that at this height, all my points has got a Z. So anything along that plane here has got a coordinate of 2. Okay. So now if you were to do C, you can see that C has got an X of 6, but it's not moved anywhere on Y. So that'd be 0. And it's not moved up or down either. So it's going to be 0. So C, if it's done properly, should be 6, 0, 0. Yeah. So it's only got a displacement on the x-axis. No displacement along y, no displacement along z. If there are no displacement along any axis, you just put a 0. So we've done A, B, C. Now D. D has got x equal to 6. Yeah? Because if you were to move D back, remember D is along a y-axis here. If you want to move back D, D would just meet C at 6 here.
It doesn't go up.
It doesn't go up,
Mhm.
but it goes along y by
So
1.
why?
So it's got a 6 for x, a 1 for y, and 0 for z. So 6, 1, and 0. Okay. So we've done A, B, C, D. Now for E, let's think about E this time. So if I'm looking at it, when I come back from E towards this axis here, E is up somehow. So that means Z, I've got a value for E. It's probably going to be 2.
Mhm.
Have I got a value on Y? Yeah, I've got a value on Y as well for E, which is 1 along Y.
Yeah.
But as E moved along X though, remember if you were to bring that towards here, E would just go down here. It's not moved left or right. So that's why on E you would get 0 for X. It might be the hardest to see. So think about if you had another plane here. F, I've got a Z value straight away. I've got no Y value because you can see if you were to bring down F, it just hits, you know, the origin here 0. And again, no value for X either. So no X, no Y. So that's 0, 0. And it's up by 2. So it should be 0, 0, 2. What about G?
0, 0, 0.
So yeah, so G is the origin. Basically, the origin is always 0. So it's not moved on X, it's not moved on Y, and it's not moved on Z either. So G would be 0, 0, 0. So the next question they might ask us is, what is the coordinate of H? This one there. So no, it's got no X, because remember that plane here, 0, 0, 0 are always 0. It's got a Y of 1, and it doesn't have a Z either. So it should be 0, 1, 0. Okay, so these are the type of question you may get. So we need to practice a few in order to get a bit more into that groove, okay? But again, it will help folks that can see things in 3D. So if you've got a bit of artistic mind in you, it may be easier. So don't beat yourself up if you think, oh, I just can't see this. I can't. You just need to have a process to help you get those. So sometime I would mention you a plane. Sometime I would say, bring that back. But when you bring it back, if you bring it back along the y-axis, make sure you follow the y direction. When I say bring it down, it's along the z direction. If I say to you G to C, it's along X. Okay, so let's have a look at some other ones. So we've done this. 3D coordinates is something quite important. You will probably have seen on some past paper questions, finding coordinates. But the 3D vectors themselves, the good news for you is all the rules that we looked and applied for when we were doing 2D vectors, those rules are the same for the 3D vectors. Okay, so what do I mean by that? Is you can add two vectors. So this time you'll notice that we've added one more component when I write in component form. So this time u, instead of having two coordinates, it's got three of them. So 3, 4, and 1. So if I was to represent this vector, it'd be 3 along the x, 4 along the y, and 1 along the z. So you can see where it would end up if I'm asked to draw this. Yeah. V, 2 along, -5 for y, and 2 up. So now if you are looking to do u plus v, you just add the top component, 3 and 2, 4 and -5, and 1 and 2. And that becomes 3 plus 2, 5, 4 minus 5, -1, 1 plus 2, 3. So this shouldn't be hard if you've understood what we did when we were doing 2D. Yeah, you just added an extra line, which represent your Z. In general, we have for vector U and V, if U is ABC and V is DEF, so remember ABC just means it could be any value for A, any value for B. It's just to give you a general formula. U plus V is just A plus D, B plus E, and C plus F. Just what we did with the numbers, but this time we've got letters. Okay, so we've done adding vectors. What would it look like now if I'm asked to find this time the magnitude, or what we call the length of the vector represented by those two bars? Okay, so remember, whenever you're going to see those two bars in mathematics means absolute value, so it's always going to be a positive value. So no matter what you do, you're going to have to take a square root, and there are no negative square roots unless you go into a different level of math. So advanced higher would look at negative square roots, okay? But at this level, no. So a square root is always positive. A magnitude is always given positive. Remember, you've got the direction to tell you if it's going up, down, you know, left or right. So the only thing you need is really the magnitude. So let's say I've got this vector here, V. We've been told, looking at this, that you've got 3 on the X, 2 for Y as its component, and 1 for Z. So now if I'm asked to calculate the magnitude of V, you can just use what you've done when you were looking at 3D Pythagoras. Remember during that prelim question we had with the umbrella trying to fit inside the box? It's exactly the same thing. So you use 3D Pythagoras with 3, 2, and 1. And x squared plus y squared plus z squared would give me 3 squared plus 2 squared plus 1 squared. That is 9 plus 4 plus 1, which is 14.
So you use Pythagoras' theorem for...
Yeah, for 3D. So you use that as well for magnitude. And that's why when someone in school was asking me, where do I need Pythagoras for? you'd be surprised how much of softwares for games are used that are using this everywhere. Okay, so they use tools, they use things that are using this by default. Okay.
You might need to tell that to some of the kids in my school. They all think they're going to be YouTubers.
Yeah.
They all want to be YouTubers. They don't need maths.
Yeah. Oh, yeah.
Well,
They'll be
but
surprised.
then again, you know, even YouTubers might need maths.
Need a bit, you know, to understand it, a wee bit.
I'll let them know
Okay.
tomorrow.
So now, whenever I see this square root 14 in my head, I need to say, oh, can I simplify this? We can't really, because 14 is made up of 2 times 7, and both are prime numbers. So that means I can't simplify them. So you just leave it as root 14. Again, so that's another question you need to ask yourself whenever you're going to be faced with, to nail those last marks, you know, the ones that are going to get you the A at the end. So subtracting 2 vectors, very simple. Adding, you add the components, subtract, you just take them away. So 6 take minus 2 is 4, 5 minus 4 is 1, and 3 minus 2 is 1. So that's how you'd subtract 2 vectors. So in general, if you've got A, B, C, D, E, F, U minus V just become A minus D, B minus E, and C minus F in its component form. Okay, quite straightforward. Now we look at position vector in 2D land. You know, when I said OA, you've got X and Y, OB. So it's exactly the same thing here, but we just added an extra line. So if I'm looking for OA here, you would write the component for A, the point is 3, 2, 1. And OA, you can represent it as a vector A with the component of that point A, but written in the column rather than being written in a row here. So you can see now using XYZ coordinates into the vector land. Okay, so they represent point A of vector OA. If R is 2, negative 5, 1, and S is 4, 1, negative 3, so I've got 2 points, you could be asked to find the vector RS. It's just the same way we did AB, B minus A, RS is just S minus R. So you would put these into component form and you do S minus R. So 4 minus 2, 1 minus minus 5, which is plus 5, negative 3, negative 1, which become negative 4. Okay. So 2, 6, and negative 4 are the components or the representation of the vector RS in its component form using 2 points. Okay, so for homework, what do I have for homework? I've got 29A question 1 and 30B question 2. So you would need to go to page 320 and 326. So we get towards the end of the book, really. After that, it should be only 320. You've done quite well to get to that. Okay, so let's have a look at a couple of them just to get you started. So the first one we're not going to do because it's part of the lesson. It's probably the easiest one. So have a go at this, try it, and only reveal the answers once you've done it. The second one, also, let's check the question. For each diagram, write down the coordinates of the vertices shown. So basically, you've got to write the coordinate of A, coordinate of B, C, D, E, F, G, H. So quite a few, but then you can double check them because the answers are on the right. So let's have a look at this one, for example, or we can look at this one. Up to you. Let me check. I've got this. Oh, I've got this one. I've got 4 of them, I think. Yeah. So which one would you rather? I'm not going to do all different points, but maybe this one that's been shifted is probably not a bad one to look at. Or would you rather do something like this?
That looks quite tricky.
Cuboid, yeah.
Like a triangle. There's like a 3D triangle.
So yeah, so let's have a look. How would you approach something like this? Okay. So obviously they've only given us 1 point here. They've helped us by saying that. Yeah, so they've given us 1 point and by how much C is moved on the y-axis. So you went from B to C here, going along by 4. Okay, so on the y-axis, I've got 4. So if I'm asked A, I'm not going to go through A because A is just your origin, right? So A is 0, 0, 0. Now, one that might be a bit difficult is probably E. E is probably a difficult one, but the rest should be pretty straightforward. Okay, so let's have a look how we would do this. So we've done A. To do B, you look along X by how much I've moved.
12.
Exactly. So F is telling me here
The
on
12 is
that
the
plane that B has got a 12. Oops, I need to change the color. So B has got 12 in X. So in Y, if you move along B towards the center here, you can see that I'm cutting Y at its 0 point there. So that means Y is 0.
yeah.
And then in Z, same thing. When I move back B towards the Z axis, I'm not cutting it above that 0 point. So that means Z's got to be 0, right? Okay.
Is your mouse gone again, Adrian?
Yeah, I think it's my laptop is just 10 years old, and you can feel that there's so many software inside it that are. So whenever I connect
Yeah.
the pad, it seems to just struggle like this. Anyway, we'll get there. So C, so I've done B. C again, if I move C towards X, we cut it at 12. In terms of Y, I would need to go towards the y-axis. And I'm cutting it at the point D here. But they've told me here you've got 4 units. So I'm cutting Y at 4 here. Because that 4 units here is the same 4 units that you would get there. And now, have I gone up? No, it's still on that plane there where it's 0. So you would just write 12, 4, and 0. Okay. They've given us F, 12. Now you might think, okay, the Y, you're at 2. Yeah, because here you've got what we call an isosceles triangle.
Mhm.
That means you cut here at 2, halfway through your 4 here. Because that's a prism, a perfect prism that you've got. So you cut it at half 2, that's why it's got 2 here. And then you're up by 4 according to them. So that FE here, we just cut the Z-axis at 4. Okay. So A, B, C. To do D, we've got 0 on X. So if I was to draw a line back towards X, you can see that I've not moved left or right from the 0. On Y, I've moved by, like I just said there, by 4, yeah?
Yep.
And on Z, it's not gone up or down, so it's got to be 0. So A, 0, 0, 0. So we've done basically all the points at the bottom. Yeah? 12, 0, 0, 12, 4, 0, 0, 4, 0. Now, F is 12, 2, and 4. E, in terms of X, E is not moved left or right. So E's got to start with 0 for X. For Y, it's at the same position as a F, which is halfway between the 4. So we're halfway there in terms of Y. So if you were to draw down the line towards the Y-axis, you'll cut it at halfway of 4, which is a 2. And for Z, it's exactly the same as F, which is just 4. So let's check that we got them all right. So 0, 0, 0, 12, 0, 0, 12, 4, 0, 0, 4, 0, 0, 2, 4, and the last one was given 12, 2, 4. So you just need to take your time
Yeah.
and look at how is it with regards to X? How is it positioned with regard to Y? If you're not too sure, try and bring it along towards Y. For example, if you struggle with C in terms of Y, you're not too sure, bring it along towards Y, and you'll see that you just moved it by that amount. But to be honest, they gave us here the amount of Y needed, so which was 4. If you wanted to know as well for Z, you would need to bring it along the way here and down the way towards Z, and you will see that you've not moved. So any points on that plane, the bottom plane, for Z are always, all of them will be 0. Okay. So you'll be able to try this one. The only thing with this one is it's a bit like the same one as we did at the start, but they've just shifted it by -2 on X. So you've got a -2 here, -1, -2, whereas here on X, you've got 1. Okay. So it's a third of the box in volume is still on that side, and 2/3 are on that side. With regard to Z, all the Z will have to be positive or 0. In terms of Y, they're all positive as well or 0. So it's only X that you're going to have some negative values. Okay, and this one being -2. And this one being +1. And if you were to look for that distance here on C, it's the Y. It's the same Y displacements as G, and it says 2 here, yeah. So that's why this is going to be 2. 1 here, 2 there. So for Y, you've got a 2 here. So if it helps, you could already start writing them. And because you've got a cuboid, you've got 2 as well here. So that's another way to help you out. -2 here, +1 in that side. Okay. So if I was to do, let's say we do F, right? For the sake of it. So F, I'm looking at X. When I bring down F towards X, is at 1. Yeah.
Mhm.
In the Y-axis, f, if I bring it down along the y, is at 0. So you just get down here along to touch the y-axis is at 0. And then for z, so f is here. So z is got the same z as g, because that's the plane at the top there, cutting z. And g being 3, f is got to be 3. Okay. So 1, 0, and 3. And you can see that from 0 to f, you went 1 along x. You've not moved in terms of y, so you stayed put, and you went 3 up. So you can quickly check that your 103 does make sense. Okay, so it's another way for you to check once you're done. 1, 0, 3. Okay, and the next exercise, so you'll have a go at this one. This is going to be a bit more challenging, but you need to struggle in order to learn a wee bit on it. So the next exercise is just calculating the magnitude of the resultant vectors, leaving your answer as a third. So it's the same exercise. So we're going to do f. Okay. So let's try and do f. How would we do f? To calculate the magnitude, I need to find the vector first. So I'm adding 2 vectors. So if I do 2 plus -2, it's 2 minus 2 is plus 2 add on -2.
0.
Yeah.
0.
So basically, you go 2 that way, -2 back, you've moved 0. 7 plus 4,
11.
11. And the last one, -1 plus 4, is just +3. We just write it as 3. So that's us. We found the first one. That's the vector. Basically, it's the resultant vector. But look at the question. Calculate the magnitude. So we're going to use 3D Pythagoras. So the magnitude of this vector, so we're going to call it f, right? So magnitude of f, you write it like that, equal square root of 0 square plus 11 square plus 3 square. Okay. 0 square is 0. 11 square is 121 plus 9. So 121 plus 9 is 130, yeah?
Yep.
And we put the square root here. Jeez, that's not me.
Just
Mind of
like
his
you
own.
had a really busy day and you just thought, I'm having enough. Just start drawing. Just.
I know that would be
It's all right.
disastrous.
We've all had days like that. Don't panic.
So they've asked us to give this as a third in its simplest form, right? So now this is a time where I'm going to have to try and see, can I find a square number? So whenever you hit something like that, you go through the different square numbers that you know. So you've got 4, you've got 9. Or the other thing you could do is look at the number and say, is there a prime number here? So 13 is a prime number. So you can do 13 times 10. But 10 is 2 times 5.
Yep.
So they're all prime numbers. That means I can't do anything with this. The simplest form is just 130. You just leave it like that. In its simplest form is just square root of 130. Because I've got prime numbers.
Gosh, that must be difficult trying to fight with that pen.
I know.
Or as
It's like,
a
you know,
nightmare. It's going all over the place.
oh.
Someone might think like I might be suffering from
I'm a stroke.
Alzheimer, or is it what's the other one?
Having a stroke.
Parkinson, yeah.
Having a
Anyway,
stroke from doing that 5 maths, yeah.
still all right. I know. That's technology for you. So root 130, we've got to leave it as root 130. So I could see that it's not a multiple of 4 because if I have 130, I get something with a 5 at the end, right? 50 plus 15, that's 65. No? Yeah. 120 plus 10. So 65, I can't divide that again by 2. So 4 is gone. 9, it's not a multiple of 9 because if you add 3 and 1, you get 4. So you could see how quickly we get stuck. Because the next one after 9 would be, so 2, 3, 16. So you can't get 16 out of this. Then 25. Now, basically, it's not 25 times something. That would give me 130. Okay? Because you need 125 for 25. So you just leave it like that. There you go. Okay. Oh, by the way, 11.25, that's not in its simplest form. I don't know why they put that, but I just pulled that from the book. You could write that into a simpler form than that. So don't take that, okay? That's not the sod written in its simplest form. Yeah.
Yeah, that's not.
So I just trusted the book's answers, but there you go. It just shows you. So you're gonna have to find the correct answer for me next time. Okay, so those are the homework for 3D vectors. So we've completed the vectors lesson. Okay, so it's good that we had started with the 2D. So we can have a look at some past papers just to give you an idea what kind of question you will get with vectors. And once we've done that, we'll take a wee break. And after that, you guys are going to show me that you've done your 5 a days. Remember, if you eat 5 of something a day, it keeps you healthy.
I do that with coffee. Adrian, I do that with coffee. Does that count?
No, that's a no.
That's a no. The heart rate's going through the roof.
I don't think. I'm glad I'm not a coffee drinker because.
Yeah. Oh, try working in a primary school. Yeah, that's you need coffee. You need coffee.
Okay. So